Now, in this video, we continue with our discussion of parallel lines and transversal lines. Now, this is still a subsection under the concept of Euclidean geometry. Now, we have had discussions about alternate interior angles. We saw what it means by definition and how the mathematical illustration can be examined. We also discussed co-interior angles, also known as same-side interior angles. We also saw under co-interior angles that co-interior angles, which are this angle and the other angle, they are supplementary, meaning they add up to 180. The other property that we are yet to discuss now is the concept of alternate exterior angles. Now, alternate exterior angles, they are indicated by this blue, by these blue shadings here. The property that we have is that alternate exterior angles are always equal to each other. For example, that means if this is 50 degrees, the other one is also 50 degrees. If this other one is 60 degrees, then this other one is also 60 degrees. That is what we would like to have for our discussion of now, alternate exterior angles. I will illustrate that with a much bigger illustration. Here we go. Excuse me. So alternate exterior angles, there are these angles here, this one here in blue and that one. They are known as alternate exterior angles. They are closely related to alternate interior angles in terms of their properties, but they are not the same. For alternate interior angles, we would either have this angle and the other one, or we would have this angle and that one. That would be for alternate interior angles. But this one we are discussing is alternate exterior angles. That is what we would like to investigate in this lesson. Now, we will be moving real quick into checking some few activities just to help us have a better understanding of what these alternate exterior angles are. So by definition, alternate exterior angles are the pair of angles that lie on the outer side of the two parallel lines, but on either side of the transversal line, okay? Now, what I'm trying to say by definition is that if you have two parallel lines, this line here and the other line, now you have a transversal line, this one here. So from these two parallel lines and the transversal line, we get the outer angles, which is this one here and this other one, and we call the angles alternate exterior angles. So then what else do we know about alternate exterior angles? Well, the good news is that alternate exterior angles, they always have the same value, always. Meaning if this lower angle is 30 degrees, this other upper angle must also be 30 degrees. So here is the question. How can that concept, that claim, be examined? How can it be used? All right, let's have a few activities to illustrate how alternate exterior angles can be examined. Okay, so here we go. We have a list of activities. The first activity is that we identify as either alternate exterior angles or co-exterior, rather same side exterior angles. And later we find the measure of each angle indicated. Well, look at this angle and this other one. This lower angle is 62 degrees. These are parallel lines, this line here and the other line. And this one is known as the what? The transversal line. Now, this angle 62 degree and this other angle, they are known as alternate exterior angles. And the other thing is that these angles are also the same. That is for the first activity, part 1. The first activity, part 2, we also have two parallel lines. Then we have what? A transversal line here. Now, because of the presence of the transversal line, we have what? We have this angle 132 degrees, and we also have this other angle. Now, notice that this other angle, this and that, is also, that is, these two angles also form alternate exterior angles. That means this angle is the same as the lower angle, meaning this lower angle here is also equals to 132 degrees. Well, that is not all. There are times when we are required to solve. For example, look at this second question. So under this, excuse me, under this activity, we still have this question here that we have to solve for x. The question is, how do we solve for x? Well, since this angle here, 110 degrees, and this other angle, 14x minus 2, they are alternate exterior angles. That means they are also the same. So how do we start that? Well, we say 110 degrees, okay? The angles right here. The angles 110 degrees and 14. Well, let's put this one in the bracket. We can have this one in the bracket. 14x minus 2, also in degrees. Yeah, okay, so these two angles are what? They are alternate exterior angles. That's the first thing we want to put right there. So we say these angles exterior yes, that is the first claim that we have presented. These two angles are alternate exterior angles. That is not all. The other property here is that these two angles are also equal to each other. We can therefore say 110, okay, degrees is also equal to 14x minus 12. You see that? Now, this type of illustration can help us to go ahead to find the value of what? The value of x. And so in the next step to find the value of x, what do? We do what is called collection of like terms. The terms that do not have x attached to them, they are known as like terms, and we put them together. In other words, onto 110 degrees, we add what? We add 12 degrees. Now we have grouped, or we have collected the like terms together. On one side of the equal sign, we will be having what? 14x. Now notice when we transfer 12x from the right hand side to the left hand side of the equal sign, what happens is that the two quantities, that is the 12x which was minus, becomes a plus. That is what happens. That would have also been a similar case if we transferred 110 degree to the right hand side. The sign before 110 degree would change. So remember that every time you move one quantity from one side of the equal sign to the other side of the equal sign, the sign before it will change. If it was minus 12, it will become plus 12. If it was plus 12, it would become minus 12. Now in the next step, we add 110 degree to 12 degrees. That would be 120 what? That would be 122 degrees. Now that is what we have got on the left hand side. Now on the right hand side, we still have what? We have 14x. Now in the step which follows, we now want to find the value of x. And what do we do? Well, onto 122 degrees, that is, we do what? We divide. We want to divide this quantity by 14. So that on the right hand side, we will also be having 14x, okay? The whole thing. We also do what? We divide by 14. Now what then happens is that we are going to be left with x on one side of the equal sign, okay? So on one side of the equal sign, we are going to be left with x. That is on the right side of the equal sign, we will be having x. Then on the left of the equal sign, what do we have? We then have to divide 122 degrees by 14. Then we will have to use a calculator to do that. So to use a calculator to do that, we will have to, well, get into the calculator and we divide 122 by what? By 14. That would give us 8.7 degrees. So we say 8.7 degrees is the value of what? Is the value of x. So yes, you see, after getting the illustration of alternate exterior angles, the fact that they are the same can help us to find some quantities that were not initially known. This way, we have been able to find the value of x. So we had it that 110 degrees is equals to 14x minus 12. So to find the value of x, we first need to sort things out. Sorting things out means we group the like terms together and the terms that are not like separately. So the like terms in this case includes 12 degrees and what? 110 degrees. So we put 12 degrees together with 110 degrees. That way, we will be adding 110 degrees to 12 degrees. Since initially 12 degrees was on the right hand side and it was minus, when it is moved to the left hand side, it will become a plus. On the right hand side, we will then be left with what? 14x. And so when we add 110 to 12 degrees, we get what? 122 degrees. On the right hand side, we remain with what? 14x. This way, we can find the value of x after dividing 14x by 14. Now notice that we will do the same. That is, we will also divide 122 degrees by 14. That way, we can find the value of x. And the value of x in this case is what? 8.7 degrees. That is how we can use the fact that alternate exterior angles are equal to each other. Now, we can move on to the next activity. This was activity 2. Activity 1, part 2. Activity 1, this one was part 2. Well, we can move on to the next activity, that is activity 1, the next part. And what is that? Well, here we also have to solve for x. So we have 125 degrees, then 11x minus 7 degrees. Now notice that these two angles are also what? Alternate exterior angles. So the first thing is to write that 125 degrees and 11x minus 7 are alternate exterior angles. So this is now activity 1, part 2. Well, this was part 1, this is part 2, Roman 1, part 2, subsection 2. There we go. So we are now talking about two angles, and what are they? 125. All right. So let's have it written down here. So this is another question. Let's call this one part 3, just to make it a little bit easier for us. Now we have got 11x minus 7, and what? Let's have this inside the bracket. Okay, 11x minus 7 in what? In degrees. And what? And the other angle, which is 125, also in degrees, are what? They are alternate exterior angles. Yes. So these are the angles we're talking about. This angle here, 125 degrees, and the other angle right up here, 11x minus 7. This angle and the other one, they are known as alternate exterior angles. And because they are alternate exterior angles, we can go ahead to use that concept to help us do what? Find the value of x. Well, these two angles, we say, are alternate exterior angles. So let's put that down. We say these angles here, the angles, that is how we write it, the angles 11x minus 7 degrees and 125 degrees are what? Alternate exterior angles. Well, then what do we do with that property? Well, that then means 11x, okay, minus 7, 125 are what? Are the same, or they equal each other. That is 125. Yes. Since they are alternate exterior angles, we also say they are the same. That way, we can go ahead to find the value of x. Now, in the next step, we do what is called collection of like terms. Now, with collection of like terms, we transfer 7 from left-hand side to the right-hand side, because 7 and 125, they are known as like terms. They don't have x attached to them. They can add together. They can be grouped together. They are known as like terms. In the next step, then we will be having 11x on one side, and on the other side, we will be having 125 plus what? Plus 7. What we did was to transfer 7 from the left-hand side to the right-hand side, because 7 and 125 are like terms. Now notice that 7 is minus from the left-hand side. That means afterwards, after transferring it to the right-hand side, 7 will become a plus. Now in the next step, we will then be having 11x on the left-hand side, that is on the left-hand side. Then when we add 7 onto 125, what we get is 132. We are so close to concluding. Now in the next step, 11x is going to be what? It's going to be divided by 11. Why do we do that? Well, we do that so that we can find the value of x without anything attached to it. Now on the right-hand side, we have 132. Now since we divided 11x by 11, we also do the same to what? To 132. That is what you did on the left-hand side of the equal sign must also be done on the right-hand side of the what? Of the equal sign. So now notice that we have to divide what? 132 by 11, since that is what we did on the left-hand side. This way, then we can find the value of x. Well, what is it going to be for x? Well, we get our calculator and we say 132 divided by 11, we get 12 degrees. So we write it down as 12 degrees. Yes, this is what we get for the value of x. Now, the next question. Well, let's check what the next question is. This was question 1. This is question 2. Now question 3. Question 3 part 1. Okay, let's write it as question 3 part 1. Because this one here and activity 1, this one should have been part 1 of question 2. This one was question 2. Part 1. Then question 2, part 2. Now we go to question 3, part 1. Okay. We move to question 3, part 1. Yes. Now in question 3, part 1, what we are supposed to do is to find the measure of the angle indicated in bold. Well, what we are supposed to do is to find the value of 4x plus 4. That then means we must first find the value of x. And how do we find the value of x? We use the property that 14x plus 4 and this other angle, 13x plus 13, they are what? They are alternate exterior angles. And since these two angles are alternate exterior angles, we can also go ahead to say they are equal to each other. So that means in our next step, we will then be having, we say these two angles. All right. What are the angles? 14x plus 4. All right, 14x plus 4, then 13x plus 13. So we say the angles, all right, the two angles, and what are they? The first one being 14x plus 4, well, obviously in degrees, and what? The second angle, which is what? X plus 13. Okay. We say these two angles, this one here, 14x plus 4 and 13x plus 13, they are alternate exterior angles. That's the first thing we want to introduce. All right. So we say these two angles are what? Alternate exterior. Now, because they are alternate exterior angles, that means the two angles are also equal to each other. Okay, we can equate them, we can make them equal to each other. And that way, we will be having what? 14x plus 14 is one angle on one side, okay, of the equal sign. Then on the other side of the equal sign, what do we have? We have 13x plus what? Plus 13. We put it where? We put it on the other side of the equal sign, that is right hand side. Since the two angles are alternate exterior angles, that means they are also equal to each other. Now, the next thing we want to introduce here is, that is in the next step of equating the two angles, we now want to collect like terms. Collecting like terms then means the terms or the quantities having x attached to them, we put them together. Then the quantities not having x attached to them, we put them separately. Well, what this means then is that 14x and 13x must be put together. Now remember that 13x is on the right hand side and it is positive. And so when we transfer it to the left-hand side, 13x is going to be minus. So we will be having what? 13x. Now on the left-hand side. On the right-hand side, we will be having this 13x, this 13, which is positive, and from it we take away 4. Now notice that 4 previously was positive or plus from left-hand side. So when we move 4 from left-hand side to the right-hand side, 4 is going to change its sign from plus to minus, which is what we have right here. Now in the next step, what we have, which is 14x minus 13x, will now reduce to what? Will reduce to x, because 14x minus 13x is going to be x. It's like trying to say you had 14 oranges. Now a friend requested you and you gave out 13 oranges. Of the 14, you gave out 13. So what do you have? You just have only an orange, or one orange. An orange in this case is represented by x. And so on the right hand side, what shall we have? We shall have 13 minus 4, which is what? Which is 9 in degrees. Now, what we are supposed to find is the value of 14x plus 4. We can therefore say that 14x plus 4 then be equal to 14 times x, okay? 14 times x, and what is x? X is 9. Then on it we have 4. This way, what are we going to get? Well, when we add 14x times 9 to 4, we will want first to simplify 14 times 9. And what is 14 times 9? Well, 14 times 9 will give us 126. So we have 126. Now on to 126 we add 4. That will give us 100 and what? 130 degrees. What that then means, is that this 100, well, this value which we have got here is also equals to this other one. That means if this is 130 degrees, this other one must also be 130 degrees. We can check that out. Let's check just to be sure, just to confirm. So we have got from the expression 14x plus 4, we have got what? 130. Now we want to check with what? 13x plus what? Plus 13. We're also going to get 130 degrees. Now this part of checking is not necessary during examination time, but just to make you and help you have a proper understanding and a proper evidence of the what? Of this theory, we want to prove it out. So this will then be 13x. And what is 13x? This is 13 times 9. We are adding 13. Well, let's see. What do we get when we multiply 13 by 9? Well, 13 by 9 gives us what? Gives us 117. So we write this as 117. Now, when we add up to 117, we add 13. What do we get? Well, we still get 130 degrees. So that means this theory is true and it works. We now move on to what? We now move on to question 3, part 2. Now in part 2, what are we supposed to do? Well, in part 2, we have this. The same question is still that we find the measure of the angle indicated in bold, which is this one here. It is bold, it's like block. Then we have it as 8x plus 4. On the other side, we have 9x minus 3. Now notice that these two angles are also what? Alternate exterior angles. And so we can say the two angles given for us, okay, what are they? Well, we say the angles. Let's take again, 8x plus 4, the angles 8x plus 4. We could use a bracket for that. 8x plus 4, which is, let's check, that angle is 9x minus 3. Yes, the next angle is 9x minus 3. The next angle, which is 9x minus 3, we say these two angles are what? Alternate exterior. Yes, these two angles are alternate exterior angles. Now, because they are alternate exterior angles, we can equate them. In other words, we can make 8x plus 4. Okay, we can make 8x plus 4 be equal to what? Be equal to 9x minus 3. So when we have it right there, we can then go ahead to do what? To find the value of x. Now, in this next step, finding the value of x will require sorting out or grouping, or what we call collecting like terms. Now, collecting like terms then means the values or the quantities where there is x, for example, 8x and 9x, we put them together. Then these other ones without x attached to them, we also group them in their own ways. So what do we do then here? Well, we can decide to transfer 9x onto the left-hand side, so that from having 8x only, we will transfer 9x. Notice that 9x is on the right-hand side and it is positive. So because it is positive, we can transfer it onto the left-hand side and it becomes negative. Then now onto the right-hand side, what do we have? Well, we have negative 3, which will be having 4, to it. So 4 is positive on the right-hand side, meaning on the left-hand side, 4 will be negative, will be minus. What do we do then here? Well, when we take away 8 oranges, rather, when we take away 9 oranges from 8 oranges, it doesn't really work right. It's like you're taking away a bigger quantity from a smaller number or a smaller quantity. It will not be fine. It will be a minus. That is, if someone comes to borrow money from you, money that you don't have, you basically have to go to some other person and borrow from them before you give this one. Now, because you have borrowed from someone else, you are in debt, you are in minus, you are in deficit. So we say minus x is going to be, well, minus 3 minus 4 gives us what? Minus 7. And so from here, can we find the value of x? Yes, we can find the value of x. And how do we find it? Well, we say minus x divided by what? We are going to divide minus x with minus 1. Then we are going to do the same on the right-hand side. In other words, we are going to divide minus 7 by what? We are going to divide minus 7 by minus 1 also. Yes, we want to divide minus 7 by what? Minus 1. Can we get the value of x from here? Yes, because minus x, when divided by minus 1, we get plus x or positive x. This time equals to what? To 7. Yes. Now, the question that we are supposed to handle is that we have to find the value of 8x plus 4. So we then say 8x plus 4 to 8 times x. What is the value of x? Well, times 7. What is that going to be? Let's check. So 8 times 7 gives us what? 56. So we therefore write 56 8 to 4. This one will give us, well, it will give us 60. So this is the value in degrees of what? Of 8x plus 4. Now, we could also check with the what? With the remaining quantity. Let's check just to confirm if we will also get 60 degree from 9x minus 3. So from 9x minus 3, well, 9x minus 3 then be 9, okay, times x. That is times 7 minus 3. What do we get when we multiply 9 by 7? Well, 9 by 7 will give us 63. Okay, 9 by 7. Let me check again. 9 multiplied by 7 is giving us 63. Yes. So we write it as 63 there. From it, we are supposed to subtract 3, which is this one here. We are subtracting this 3. What do we get? We get 60 also in degree. So now, because we have got 60 also in degrees, and it is the same as that, we can therefore conclude that alternate exterior angles are always equal to each other. This is it for this lesson. You should then be able to attempt any question which requires the application of the knowledge of the property of alternate exterior angles. Okay, alternate exterior angles, they are equal to each other. This one leads us to the end of this lesson. Please get ready, as I will be preparing for you an activity to do in relation to this concept of alternate exterior angles.